Hello guys, my name is Kirtan and welcome to my channel Physiology at Once. Today I will be talking about the topic blood coagulation. This is the first part of this topic. I will upload the next part in the next video. The blood coagulation topic is very important and can be asked in the board examinations for 5 marks or also can be asked for 10 marks. In this video we will be talking about the mechanisms of blood coagulations and how to remember the clotting factors with some mnemonics. So let's start. Coagulation is a vital physiological process as it controls the excessive bleeding. As we know, without coagulation there will be excessive bleeding and hemorrhage which will ultimately cause anemia and the patient may go to coma due to hypotension. In the previous video I had talked about hemostasis. I had told that hemostasis can be again divided into temporary hemostasis and definitive hemostasis. In that video I had talked about temporary hemostasis. And today I will be talking about the definitive hemostasis. Definitive hemostasis is nothing but the coagulation of the blood. It is activated immediately after the activations of the platelets. The blood coagulation process occurs in 3 major steps or stages. The stage 1 is activation of stored power factor or factor 10. Stage 2 is formation of thrombin from prothrombin. And stage 3 is formation of fibrin from fibrinogen. Before talking about the stages, let's try to remember the clotting factors with some mnemonics. The clotting factors can be asked as a sub question in the board examinations as enumerate the clotting factors. So it is very important to memorize these clotting factors. So I will talk about these clotting factors. These are mainly produced in the liver as plasma proteins. There are totally 12 clotting factors in the blood. So let's start. The factor 1 is fibrinogen, factor 2 is prothrombin, factor 3 is tissue thromboplastin, factor 4 is calcium, factor 5 is proaxillerin or you can also call it as labile factor. There is no factor 6, so the next one is factor 7. It is proconvertin or stable factor. Factor 8 is anti-hemophilic factor. Factor 9 is Christmas factor or anti-hemophilic factor B. Factor 10 is Stuart-Prower factor. Factor 11 is plasma thromboplasmin antecedent. Factor 12 is Hageman's factor and factor 13 is fibrin stabilizing factor. These all clotting factors are very important in the process of blood coagulation. So how to remember this? The mnemonic is freshest party today. Come let's sing and call senior. Please have fun. I will repeat it. Freshest party today. Come let's sing and call senior. Please have fun. You can write it down if you want it. So freshest or fibrinogen, party prothrombin, today tissue thromboplastin, come calcium, let's labile factor, sing stable factor and anti-hemophilic factor, call Christmas factor, senior Stuart-Prower factor, please plasma thromboplasmin antecedent, have Hageman's factor and fun fibrin stabilizing factor. I hope you are thorough with these clotting factors with the mnemonic. So let's start with the stages of the blood coagulation process. The stage 1 is activation of Stuart-Prower factor. Stuart-Prower factor is nothing but the factor 10 as you studied now. It is also called as prothrombin activator as it helps in activating the prothrombin to the thrombin. It is achieved mainly by 2 pathways, intrinsic and extrinsic. Talking about the intrinsic pathway, it occurs in 4 steps. The step 1 is activation of clotting factor 12. The clotting factor 12 or Hageman's factor as you studied now attaches with the exposed collagen of the injured vessel wall and gets activated. The high molecular weight or HMW kininogen and kallikrein acts as cofactors to facilitate this activation of factor 12. So the next step is the activation of clotting factor 11. The previous step there was activation of clotting factor 12. So this activated clotting factor 12 now converts the clotting factor 11 to its activated form. The HMW kininogen facilitates this process. The step 3 is activation of clotting factor 9. So the same process, the activated version of the clotting factor 11 converts the clotting factor 9 to its activated form. 9A meets the activated form of the clotting factor 9. The activated version of clotting factor 7 and calcium facilitates this process. The step 4 is activation of clotting factor 10 or stored power factor. The activated clotting factor 9 causes this activation of the clotting factor 10. The membrane phospholipid, calcium and activated factor 8 acts as cofactor to facilitate this process. So you can see this as an positive feedback mechanism. Example, one factor activates the another factor and this goes on. Now talking about the extrinsic pathway, it occurs in 3 steps. The step 1 is release of tissue thromboplastin. In this step, there is release of TPL or tissue thromboplastin from the injured tissue. This pathway is mainly called extrinsic because this tissue thromboplastin is released from the injured tissue, which is extrinsic to the circulating blood. So that's why it's called extrinsic pathway. The step 2 is activation of clotting factor 7. The TPL or tissue thromboplastin converts the factor 7 to its activated form. It is the key step in this pathway. The activated version of the clotting factor 7 activates both factor 10 or stored power factor and factor 9, thereby influencing the intrinsic mechanism. So there is a link between both extrinsic and intrinsic mechanism. The step 3 is activation of the clotting factor 10. This is the final step. The activated clotting factor 7 converts the clotting factor 10 to its activated form. Calcium, platelet, phospholipid and TPL accelerates this process. So now let's talk about the stage 2 of the coagulation mechanism. In the stage 1, the main idea was to activate the clotting factor 10. The activated clotting factor 10 is required in this stage 2. So the stage 2 is formation of thrombin from prothrombin. In this stage, the stored power factor, the activated clotting factor 10, converts the prothrombin to the thrombin in the presence of platelet phospholipid, calcium and activated factor 5. So why is this thrombin important and why should it be activated from prothrombin? So it converts fibrinogen to fibrin monomers. This is the third stage and I will be talking a bit now later. It facilitates the formation of the prothrombin activator or factor 10. So it again facilitates the formation of the factor 10 activation and hence it is the positive feedback mechanism. It also activates the platelets in the coagulation process. It activates the procarboxypeptidase B. It is important in the activation of It is mainly important in the activation of fibrinolysis. Fibrinolysis is nothing but the lysis of the clot. So you can see that thrombin acts as both clotting and anti-clotting factor. So it acts as a balancing factor between both coagulation and anticoagulation. It also has anti-clotting activity as discussed now. It also helps in the repair of vessel wall. But how does it help in the repair of vessel wall? It has many growth factors. It has many growth factor like activity through which there will be repair of the damaged vessel wall. So now let's talk about the stage 3 of the coagulation process. This is the final step. The stage 3 is the formation of fibrin from the fibrinogen. It also occurs in 3 steps. The first step is proteolysis of the soluble fibrinogen. The fibrinogen will be in the soluble form in the initial stage, but this fibrinogen is lysed to form fibrinopeptides by the thrombin. That's why the thrombin is activated in the stage 2. These fibrinopeptides form the fibrin monomer. The next step is polymerization of the fibrin monomers. So these formed fibrin monomers converts into protofibrils. These protofibrils again form meshwork of interconnected fibrin fibers. In this step also thrombin initiates this process. It also activates factor 13 simultaneously. As you read now, factor 13 is the fibrin stabilizing factor, and it is important for the stabilization of the fibrin clot. The next step is stabilization of the fibrin polymer. So this activated clotting factor 13 or fibrin stabilizing factor stabilizes the fibrin polymers by cross-linking them. So there will be covalent cross-linking between these fibrin polymers and form a stable clot. This stabilized fibrin meshwork is the blood clot. So the blood clot is finally formed in the stage 3. So you can understand this as there is a fibrinogen molecule. It will be soluble and it is proteolized by the thrombin to many fibrinopeptides. These fibrinopeptides again form the protofibrils. These protofibrils form meshwork of interconnected fibrin fibers. They form the meshwork, and this meshwork are stabilized by the activated clotting factor 13 or fibrin stabilizing factor and form a covalent cross-linking between these polymers and form a stabilized blood clot. So this is the total mechanism of the blood coagulation. So as we have discussed the complete process of the coagulation, now let's revise it once again in the form of a flowchart and understand it more thoroughly. You can also draw this flowchart in your board examination. So let's start with the stage 1. There is intrinsic pathway and extrinsic pathway. First, let's talk about the intrinsic pathway. First, there will be a vascular injury due to which there will be exposed collagen and many negative substances which will attract the platelets toward it. Then there will be activation of the clotting factor 12 through the HMW kininogen and kallikrein. This activated clotting factor 12 again activates the clotting factor 11. This clotting factor 11 again activates the clotting factor 9 with the help of activated clotting factor 7 and the calcium. This activated clotting factor 9 finally helps in activation of the clotting factor 10, which is the stored power factor. It helps in activation by the phospholipid, calcium and the activated version of the clotting factor 8. Coming to the extrinsic pathway, there will be a tissue damage, due to which there will be release of tissue thromboplastin, which will activate the clotting factor 7 to its activated form. Then this activated clotting factor 7 with the help of phospholipid, calcium and tissue thromboplastin activates the clotting factor 10 into the activated form. So this is a positive feedback mechanism. One step activates the other step and the other step activates the next step. So it goes on until the final product is reached. In the stage 2, the activated clotting factor 10 converts the prothrombin to the thrombin. It is also called as prothrombin activated because of this reason. It does it through the help of phospholipid, calcium and activated form of clotting factor 5. Now this thrombin is the main thing in the stage 3. This thrombin converts the fibrinogen to fibrin by the process of proteolysis. It takes the help of calcium in this process. Now this fibrin is converted to the stabilized fibrin polymer with the help of activated form of the clotting factor 13 or fibrin stabilizing factor. So the clot is formed. So that's it for today, guys. If you found this video helpful, please like, share and comment, and also don't forget to subscribe. My mission of this channel is to make physiology easy, understandable and simple. So please support my mission by subscribing to this channel. Thank you.